And so everything that we know about thermal comfort has really come out of some studies that were done by this man named Fanger in the 60s at the University of Kansas. And it was really based off of kind of what was considered typical office workers in the 60s in Kansas, which were kind of these farm-fed Midwesterners in their three-piece suit.
Yeah, and to this day, I mean, the unit that we use to measure clothing, we have one clo, and it's a three-piece suit.
Yeah.
It's equivalent to a three-piece suit. And so it's still, a very much so what gets used a lot.
Yeah, and so today, and for today's office environment, we have a lot of women. We have office snuggies to accommodate that, because how we think about comfort isn't really has not been really adapted to the way we work today and the different environments that we have. So there's been a lot of current debate in the news about why are our buildings so cold? Is it sexist? And what about? And so this is one of the issues that we became really interested in comfort, and it's, I think, a very relevant topic currently in the industry today.
Mm-hmm. By the way, there's one nice article in that there, which is showing we have one of our coworkers in a Snuggie, which is the equivalent of a three-piece suit in terms of clothing insulation. So that's just to put things in perspective.
Okay.
So there's basically 6 factors that we use to quantify thermal comfort. There's the metabolic rate, which is what you're doing. So whether you're sitting and reading a book versus running laps around the track, you feel comfortable at very different temperatures. How much you're wearing. So if I were sitting here in my shorts and t-shirt or my snowsuit, I would feel very comfortable at very different temperatures. There's the air temperature, which is what we all think of when we think about comfort, sort of what your thermostat reads. There's the mean radiant temperature, which is the average temperature of all the surfaces you're seeing. So if you're sitting next to something really hot or really cold, you're going to notice that. Airspeed, so if I were sitting under a fan, I would feel comfortable on a hot day, but might feel cold on a colder day. And then the humidity, right? On a hot and humid day, you notice that. But there's really 4 of those factors that are influenced by design. So we can't really control what people are doing or wearing in our buildings. At least I can't. Maybe you guys have more power someday. But right now, we don't really control what people are doing in our buildings. And then, what we only really measure is one thing, is airspeed, or air temperature, sorry. And so the problem is that we have one metric that we really use to try to understand comfort when it's really affected by many of these different factors. And then how we translate that, how we can kind of translate that into understanding whether or not people will be comfortable or not, is there's two kind of versions that we use to quantify how people feel. So one's called the predicted mean vote, abbreviated PMV. And that's if we were to take a survey right now in the room and ask how many people are perfectly comfortable, and you'd say, some people would raise their hand, and that would be a 0. And then on a scale of like 1 to 3, from being really slightly cool to cold, to really cold, it would be -3 being very cold and +3 being very hot. And that's kind of the predicted mean vote. And that translates into, you can take that survey and you can translate the predicted mean vote into what's called the percentage of people dissatisfied, which is the PPD. They really like acronyms when they talk about comfort.
Okay. and the reason why it's a mean vote is because you've asked, like, let's say 100 people how they feel. Do you feel hot or cold? And then you say you average those all together, you get the mean of that. And that's where you're able to say, over those 100 people, this percentage are not happy.
Right.
Too. It's meant to be over a population, not just for an individual.
And because we can never satisfy everyone, I'm pretty much only comfortable at the temperatures my husband's hot at. So there's not really a Venn diagram of the temperatures at which we're both hot at, or both comfortable at. There's an assumption that you really can never get better than, you can't get to 0%. You're never going to have everybody completely satisfied. And so what we do is we have different thresholds that we consider acceptable for thermal comfort. And the industry standards are usually 10% or 20%, depending on how stringent you kind of want to be in those comfort thresholds.
And that's 10%.
Dissatisfied.
Dissatisfied.
Yeah.
Okay.
Yeah,
and
we want more than 10%. Dissatisfied.
But then the scary thing is also that a lot of our buildings, or at least when looking at a number of real buildings, will be on average somewhere at like 30 or 40% over the industry.
Dissatisfied.
Dissatisfied. So a lot of the times we're not even meeting these goals that we set.
Okay.
Just because we're not aware of them, or because we're only focused on that air temperature and not everything else.
Okay. I mean, folks in the audience, raise your hand if you're normally cold or hot in school or work. Raise your hand if you're normally cold or hot. Right? Like that's almost everybody, right?
Yeah, that's probably at least 50%.
That's interesting. Good point. Okay. Cool.
So, back to building envelopes and why I think you guys came. Or maybe it was just Mark.
No, it's you guys. Sure.
So we were interested in trying to understand, particularly related to glazing, because we work here in Boston. We do work all over the country, but we do a lot of work in the Northeast. And windows are a big source of discomfort in the winter.